The most powerful intelligence on Earth isn't running on code alone, it's running on atoms. We have been told that the digital revolution is ethereal, a world of clouds, invisible waves, and weightless information. We treat AI like magic, a ghost in the machine that lives in the ether. But magic requires a source, and the source of our new era isn't just imagination, it's a brutal physical hunger for electricity that is currently breaking our world's infrastructure. What most people think is happening right now is a simple supply and demand problem. They think big tech is just buying more power to keep the lights on, much like a factory might buy more coal. They see a company like Microsoft or Amazon signing a deal for a power plant and they think, oh, they're just trying to stay online. They see it as a logistical hurdle, a minor tax on progress. But that perspective is dangerously incomplete. It misses the tectonic shift happening beneath the surface of the internet. We aren't just looking at a demand for electricity, we are witnessing the birth of an energy apartheid. While the public grid struggles with aging wires and intermittent renewables, the titans of AI are moving to colonize the most stable, concentrated source of power known to man: nuclear energy. For 40 years, nuclear energy was the pariah of the modern world. It was the dirty secret of the 20th century, haunted by its own history and sidelined by a desperate push for green alternatives. But the AI revolution has fundamentally rewritten the math of the possible. AI models don't just need some power. They need baseload power. They need a steady, unwavering flood of electrons that never sleeps, never wavers when the wind stops blowing, and never disappears when the sun sets. Wind and solar are beautiful, but they are fickle. They are like a flickering candle in a drafty room. For a data center housing a trillion-parameter model, a flicker is a catastrophe. Nuclear is the only thing that provides the always-on density required to fuel the next century of compute. It is the only energy source that can match the sheer insatiable appetite of a machine that never stops thinking. Because the grid can't catch up. Our current infrastructure is a patchwork quilt of 20th century pipes trying to carry 21st century demands. If the public grid were to suddenly absorb the electricity needs of every major AI firm, it would buckle. It would be like trying to force a fire hose through a drinking straw. So the titans are doing something radical. They are moving from being customers of the grid to becoming owners of the source. Microsoft, Google, Amazon, and Meta are no longer just buying kilowatts. They are becoming direct financiers of the nuclear renaissance. They are pouring billions into the unbankable to create a private, gated energy ecosystem. Imagine a world where the most advanced intelligence is powered by a private utility. A walled garden of energy where the most powerful compute is physically decoupled from the public's needs. This is the hidden monopoly. If you own the atoms that power the AI, you don't just own the software. You own the literal foundation of modern reality. To achieve this, they are pivoting towards something called small modular reactors, or SMRs. Think of these as plug-and-play nuclear plants. Instead of the gargantuan multi-decade projects of the past, SMRs are designed to be built in factories and shipped to sites. They are the microchips of the energy world. They are the perfect marriage of industrial scale and tech sector speed. They allow big tech to bypass the not-in-my-backyard politics of massive plants and place power directly next to the data centers. But here is where the narrative gets complicated. Is this a heroic rescue mission for the planet, or a sophisticated heist of the commons? On one hand, the tech giants are the only entities with the capital to make nuclear viable again. They are providing the bankability that governments have lacked for decades. They are, in a sense, subsidizing the transition to carbon-free baseload power. They can claim they are saving the world by keeping their net zero promises while still running the most energy-hungry machines ever built. But on the other hand, there is the fear of energy apartheid. If the wealthiest companies on Earth buy up the best nuclear sites and the best SMR technology, what is left for the rest of us? If they strip mine the most reliable energy sources, the public grid may be left with the scraps, the intermittent, less reliable leftovers. We could see a two-tiered society, a high-speed, nuclear-powered elite tier of intelligence and a struggling, energy-starved public tier. It's a classic move in the history of industrialization. Whoever controls the energy controls the destiny. We are moving from the era of software giants to the era of energy sovereigns. When you combine the world's most powerful algorithms with the world's most concentrated energy source, you aren't just building a better chatbot. You are building a new type of infrastructure, one that is self-sustaining, private, and potentially untouchable by the public interest. The AI boom has fundamentally changed the math of the Earth. It has made the unbankable suddenly profitable. It has made the pariah energy source the most bankable asset in history. The question is no longer about whether we can power the future of AI. We know we can. The question is, who will own the lights when the world finally turns on? We are watching the construction of a new foundation. It's not made of stone or steel, but of atoms and algorithms. And as the gates of these private grids swing shut, we have to ask ourselves, in this new world of infinite compute, what happens to the people left in the dark?